Okay, here we go with the review of the ORQs for Proficiency 3. Okay, so we want to go ahead, and the first part we're going to work on is writing a proof for a quadrilateral. There are 4 steps you need. The first is to find the slopes. The second is to find the lengths of all the lines. The third is to name the shape. So what shape is it? Is it a rectangle? Is it a square? Or is it a rhombus or a parallelogram? And the fourth is just to justify why it is that. Okay, so let's go down and look at one together. Okay, so like we were talking about on number 1, we want to make sure we're finding all the slopes. Now when we're finding the slopes, what we're doing is we're finding rise over run. Okay, so we want to go ahead and draw in our triangle. I like to draw this triangle in just so it is easier to count. Okay, so for AB, our rise over run is 1, 2, 3, so 3, over our run of 1, 2, 3, 4, so 3 over 4. Okay, now we want to go down to DC. I like to go down here and just check and make sure it's right. It's the same slope. So that's what we're hoping for. So is that true? We still got 1, 2, 3. Yep, we got 3 over 1, 2, 3, 4. Perfect. So 3 over 4. We have 2 slopes. Okay, and then we have A over G. We need to find the slope of. Now this one's going to be a little bit odd. We haven't done any like it in a while. Okay, but its rise is 1, 2, 3, 4, 5. You can't draw the triangle. You aren't running left or right. So what you're doing is you have a rise of 5 and a run of 0. Now, if you put 5 over 0 in your calculator, what you're going to get is a divide by 0 error, okay? So really, our slope is 0, and that's what you want to know the slope is. But you're going to want that number 5, okay? Because that's the length of the line, okay? So we want to check and make sure BC is the same. Okay, we've got 1, 2, 3, 4, 5. Okay, perfect. So we've still got 5. We're not running anywhere, so 5 over 0. Which reduces to 0. So our slopes are 0, but we need these numbers 5 and 0. Okay, the next step, number 2, we want to make sure we're finding the lengths of all these lines. So all these lines we just found the slope for, we need to find the length. And how we do this, especially for the ones we can't just count like AD, we have to use A squared plus B squared equals C squared. Going back to good old Pythagorean theorem. Okay, so for AB, okay, we don't need to recount. We already counted for the slope, but we're going to plug 3 and 4 into A and B. So 3 squared plus 4 squared equals C squared. 3 squared I know is 9. 4 squared I know is 16. Okay, and that equals C squared. 9 plus 16 I know is 25. That gives me C squared. Now we don't want C squared, we want C. So we take the square root of 25, and that's going to give us 5. Okay, now we also know that we don't have to do this math again. Okay, with AB, we had 3 and 4. With DC, we're going to have 3 and 4. So we're not going to do the math again. We're just going to say DC is 5 as well. Okay, and the same goes for AD. Okay, our length of AD, when we counted it, was just 4. We didn't have to do a Pythagorean theorem on it to find that it was 5. So AB is 5, DC is 5, AD is 5, and BC as well as 5. Okay, so now we need to go ahead and name this shape. That's step 3. Okay, and it is a rhombus because it has all equal sides. Okay, a rhombus, just there it is. It's a rhombus. Okay, now that's all you have to do for step 3, but to step 4, we have to go ahead and justify. So, like I was saying, 4 equal sides makes a rhombus, as well as the fact that there's 2 sets of parallel lines. Now, when I'm saying parallel lines here, how I'm getting that is if you go back to AB and DC, you can see they have the same slope. That makes them parallel, as well as 0 and 0. Those are now parallel lines. Okay, now I want to go ahead, that's the rest of the proof, but I want to go ahead and give you a hint on number 2. We're not going to do it together, but it is a rectangle. Okay, and you want to make sure you're going back through and drawing in your triangles. Okay, it's going to look a little better on your sheet when you draw it, but make sure you draw those triangles in and then go back and find your length, slopes, and your lengths. Okay, we're going to go ahead and move on to word problems, the best part. Okay, with these word problems, you really have to be able to draw these shapes and identify if it's a surface area or the volume. Okay, now I like to do a little bit of underlining and highlighting in these problems so that I know what I'm looking for. Okay, so I'm going to read it. It says you are filling an ice chest with ice and you need to know how many ice cylinders, so we're working with cylinders somewhere, are going to fit in it. If the chest is 24 inches by 16 inches by 12 inches, and the ice cylinders have a radius of 1 inch and a height of 2 inches. Okay, so we know an ice chest is probably a rectangular prism. So we can draw our ice chest. I like to draw 2 rectangles kind of overlapping, and then you just connect all those corners. Okay, now we can go ahead and draw in our numbers. They said it was 24 by 12 by 16. Okay, now we also were told that we have ice cylinders. So to draw our cylinders, we have a circle, and they're connected. Ooh, sorry, that circle's kind of bad at the bottom, but we won't use that one. Okay, we are told it has a radius of 1 inch. So going from the center all the way to the side, that's 1. And then it has a height of 2 inches. Okay, so we want to know how many of these ice cubes or ice cylinders are going to fit into this ice chest. So we want to know the volume in this chest and the volume of these cylinders to see how many we can pack in. So to find the volume of the chest, we are going to use the equation volume equals area of the base times the height. Okay, the area of the base is going to be the base right here, kind of that I drew on the bottom, and it is 24 by 12. Now, if you had done 24 by 16, that would be fine as well. Okay, but I just so happened to draw it as 24 by 12. So the area of my base we're going to calculate as 24 times 12. Now, if you put that in your calculator, 24 times 12 gets you 288. Okay, now you are going to plug that number back into that capital B. So 288 is the area of our base. Now we want to multiply it by the height of that figure. Okay, that height is going to be 16. So 288 times 16, and that gets you 4,608. Okay, so that's one of our volumes. Okay, now we need to go ahead and find the volumes for these ice cylinders. Okay, so the equation we're working with here so we're still working with the equation volume equals the area of the base times the height. But our base changes in this because our base is actually a circle. Okay, so we're going to use the equation not base times height. We're going to use pi r squared, and our r in this case is 1. So pi 1 squared. If you do pi 1 squared in your calculator, you should get 3.14. Okay, now we want to go back and we plug this equation, that number, in for the capital B. So 3.14. Okay, and then our height in this case was 2. So 3.14 times 2 gets you 6.28. So that's the volume for one of these ice cylinders. Now what we want to do is we want to take the 4,608, the entire volume of the chest, and divide it by 6.28. So 4,608 divided by 6.28, and we're going to get 733.8 ice cubes. So we're just going to say 733 ice cylinders. Okay, so what we did is we found the volume of the whole shape and the volume of the small pieces going into it, and we took the entire volume and divided it by the little pieces. Okay, and that's all you're going to have to do. I'm going to let you go ahead and finish the rest of these problems on your own. When you're done with all the problems, go ahead and tell your teacher, and she'll give you the retake for this portion.